Hello everyone. Welcome to today's session. We are going to start with the lab for the Docker. Okay. So I hope everyone has got their VM up and ready. So we are going to start in the next 2 minutes. Let this VM come up. Okay. All right. So we are good to start now. Okay. So last time we completed with the Docker, okay, and we discussed about the how Docker can be used to run the application, and packaging of the applications can be done through the Docker, and then Docker can be used anywhere to run the containers. Okay, so the only dependency is the Docker CE or Docker daemon, and then we also discussed about the private repositories, and we also covered the Docker Swarm. So today we are going to cover the lab for the Docker, and once we have covered the lab for the Docker, we are going to start with the chef. Okay, that will be our overall roadmap for today. So quickly, let's start with the Docker. I hope everyone has got their VMs up and running. So we are running the Vagrant. Now inside the Vagrant, we are running the Docker. Okay. All right. So Let's start with our today's session. The very first thing that I want you to do is you need to assign the host name, okay? So that you remember that you are working on this node. So use hostname CTL set hyphen hostname and the hostname that you want to set. Okay, so a fully qualified domain name should be used, and just do a bash, and that should set your hostname. Another thing that we want to do is we want to open our etc host file. Now, first of all, you need to check your IP address. Okay, I have assigned it the IP of 192.168.33.15. Okay, so just make an entry inside the etc host file for the same, so that your domain is resolving to an IP address. Okay, now if I ping this, so that should work. Okay, all right, so till here we have set up our host name. Now the very first thing that the Docker requires is the Docker CE or Docker daemon to run in the backend. Okay, if you remember the architecture for the Docker, there we saw that every container that we push, so Docker makes an API request to this Docker CE. Okay, so let's very first thing that we are going to do is we are going to install it. Okay, now installation of Docker is comparatively easy. Docker itself provide you with a script which you can use to automate the Docker installation. Okay, so let me quickly show you that script and how we are going to install. So if you want to get into the detail, you just need to download the script using get.docker.com. Okay, now once you run this, it will automatically download the script for you. Okay, now you can go through the script if you like. Okay, it's basically a shell script which has been saved as an index.html because that's what browser reads. Now if you go through it you will see that it's in creating a Docker CE repo for your Linux distribution. It automatically detects your Linux distribution and downloads the Docker CE. Okay, this is the Docker C download URL which has been provided by the Docker. So Docker is keeping their packages over there. This is a mirror has been created. Okay, so the request will go there and then it will automatically install on the basis of your distribution, whether you are running the CentOS or whether you are running the Ubuntu distribution. It's going to automatically download or detect the user from which you are installing. If you are non-root, then obviously it's going to send out an error because during the time of installation of the Docker, you need a root user. Okay, but after the Docker has been installed, you should always run the Docker with a normal user like Vagrant. Okay, now another thing is it's going to fork. So I will leave this to you. You can go through it in more detail. It has all the checks and things in place to install the Docker. Okay, but we are using the script to install the Docker. Okay, so let's quit this and we are going to use the curl command to install the Docker. So simply do curl hyphen f small f s capital S L. Okay, that and https get.docker.com pipe sh. So this pipe will make sure that the script which is getting downloaded is getting a shell and it's getting executed at the same time. Okay, so once I hit the enter on this command, you will see that it automatically detects the operating system, that is CentOS 7.5, going to create a repository, use the yum to install the Docker C. Okay, all right, so the Docker installation should start now. Okay, so it's installing the script in the backend. It's pulling, creating the repositories, and it is installing the dependencies first. So yum utils is a dependency for installing the Docker. Yeah, sure. The command is curl hyphen s capital S L https get.docker.com pipe sh. Here's the command for you. Okay, just use this command. So it has added the repo and it is checking the latest stable version. Okay, and using the make package, it creates the package which needs to be installed and then uses the yum to install it on the system like that. This will always install the latest version of the Docker available. And this is what I was talking about, Docker CE. That is your Docker daemon. Guys, whenever I am entering a command, okay, and something which might take time or you need to take a backup, okay, so just take a screenshot of that. That will ease out for you, okay. So like Tawfiq, you need to go to vi etc host file, okay, vi slash etc slash host file, and you need to make an entry over there. First your IP, then your host name, okay, and you can take a screenshot when I am doing the same. I'm not sure, this is taking some time. From the Vagrant file you can get that, or run the ifconfig command, Soham. Soham, you can go through the recording on the Vagrant. Okay. In the Vagrant file, you can make the default port changes. Okay. But I will suggest you to go through the recording of that session. I have explained it how to make the changes in the default port. Okay. Here we are only going to focus on the Docker today. I'm not sure what's happening here. Usually it shouldn't take this much time to install the Docker. Okay, so seems this has progressed. Okay, so at this point, it has installed the Docker. Okay, and it also gives us a warning saying that you should add a user Docker. Okay, you should add the user. You should not run the Docker with a root user. Rather, we should, it has created a Docker group. Okay, so I can show you this Docker group. If you do cat etc groups, okay, and pipe grab Docker, so you will see that whenever the Docker installs, it creates a Docker group. Okay, and the user through which you are going to run the Docker command, you need to uh, add that user inside the Docker group. Okay, and that's what we are going to do now. Sujit, I have already shared the command for curl, like how through which you can install the Docker. So I would just scroll above and you should get the command. Okay, all right, and what we are going to do is we are going to add, as this command says, we are already having a user Vagrant on our system. Okay, so we are going to use that Vagrant user, and we are going to run the Docker through the Vagrant user only. Okay, but before that, let's start the Docker service. Okay, so you should do systemctl start Docker, and you need to make sure also run the status to check that the Docker is running. Okay, so here it is, and it shows that the Docker is running successfully. Another thing that we need to do is we need to enable the Docker service so that anytime this server gets restarted, Docker should come up automatically. Okay, so we are going to enable the Docker service as well. So do systemctl enable Docker. Okay, guys, I am going to type the command at the same time in the Windows as well. Okay, so that it's easy for you. Anyone who wants to look the command should check the chat window. Okay, start Docker system enable Docker. Okay, all right, so we have installed the Docker at this point in time. Okay, we have also started the Docker and we have enabled the Docker service. So Docker will always be running on this machine now. Another thing that we need to do is let's right now we are working with the root user. Okay, so we will switch to the vagrant user instead. Let's switch to the vagrant user. So do su hyphen vagrant. Okay, su hyphen vagrant, that will switch your user to the vagrant user. So I am on vagrant user now, and now we are going, if I show you the group for the vagrant user. Okay, so it's vagrant only. Okay, so what we are going to do is we are going to add the vagrant user inside the Docker group. So let's do that. User mod hyphen a, capital G means for secondary group. Okay, group name Docker, and the username which is vagrant. Okay, you need to do it through sudo because vagrant is a non-privileged user. He can't make the changes like that. Okay, all right, so if I do id vagrant now, you will see that the vagrant user is having a secondary group known as Docker. This is important, otherwise Docker creates a sock file on which if you are not having the access, then you can't run the Docker command. Okay, so the file that I wanted to refer you is var lib. Okay, let me show you. So it is Docker ps. So you see it is still throwing this error that it is not having the access on this, permission denied. Okay, so let's quickly see who is the owner of this file. So it's a in a Docker group. Okay, Docker group is the owner of this sock file. Now this is why it's required that the user should be a part of the Docker, otherwise he won't be able to connect to the Docker socket, okay, through which Docker is running. But if we are doing this, we are a part of a Docker group, so we should be able to run this command. What permission denied? Okay, now it's working. So what happens is, from the root user only, you need to first add the run this command, okay, and then you can switch to the Docker. Uh, the issue, if you don't add the Docker user inside the Vagrant user inside the Docker group, this file, okay, Docker run as a sock file. That is a socket. Linux socket is used for communication between the Docker, and that the owner of the sock file is either root or Docker. So only root or a user, which is a group of which is a part of a Docker group, can run the Docker command. Okay, if you haven't added the user which is trying to run a Docker command inside the Docker group, he won't be able to run the Docker command. He will continuously get an error. Okay, so this is what we have done till here. Okay, so you can modify the user using user mod -a capital G doc group name and the username. Okay, execute this through the root user instead. Okay, not from the Vagrant, from the root user. Or you can run the bash again, and after that try running docker ps. You shouldn't get an error. Okay, another thing is, you can see the details of the Docker that you have installed using docker info command. If you run the docker info command, it's going to print all the information for you. Okay, like how many containers are running, which are paused, what is the image version you are using, okay, what is the server version you are using, uh, and all the related information. It also detects the operating system details, kernel details, like that. Okay, so you can get all the information over here. So if you want to get the version information, run the docker info command. Now at this point, we have configured the Docker to run through the Vagrant user by adding the Vagrant user inside the Docker group and providing the necessary permission to the Vagrant user to run the Docker. Okay, this is how you will going to install and configure a Docker on any new system that you are going to use in your environment. The other thing is, after installing and configuring of the Docker, uh, we want to run the container. That is our main aim. Okay, so at this point, let's create or let's run our first container. Okay, so we are going to run a hello world container. Okay, so let me clear the screen now. So you can go ahead and do docker run hello -world. Okay, so what it's going to do is, it's going to make it's going to check that the hello world container is available locally. Okay, once it has checked that the hello world container is not available locally, it's going to go to the Docker hub, going to download the image from the Docker hub onto your local system. Okay, once the image is there, then it's going to start the Docker container. Okay, so let's run this command, docker run hello world. So it says it's not able to find the image on our local system. Okay, so it says on the locally it's not able to find the image. Now it's going to the Docker hub and going to download. See, it says pulling the image and the image ID. Okay, once the image has been completed downloading, so it runs the Docker container. Here is the information, hello from Docker. This is what it runs from the Docker. Okay, so at this point, the container has done what it needs to done. Okay, and the container has stopped. Okay, because if we want to keep running the container, then the backend process should keep on running. But in our case, we see that it has executed the container and the backend process has printed the message and it has stopped. How you can verify that the container has stopped? Using the docker ps command. So if I run docker ps, you will see that no container is running now. Okay, so the container which came up has stopped now. Now another thing, if we wanted to see the details of the stop container, so how we can see? So we can do docker ps -a. Okay, so here it is. If you will see, we run the hello world container. This is the container id, okay, which docker has created for us. This was the command which was executed inside the container. Okay, when it was run about a minute ago, it has exited now. It's in exited state because it has already done what it should, what it was needed to done. Okay, now another thing is, since we didn't provided our container a name, so the Docker has automatically created a comic name for our container, which is Happy Stonebreaker. Okay. We can also refer to the container either with the container ID or either with a name which the Docker has assigned to our container or the name which we have given to our container. Okay. Soham, for this error, just go back to the root user and switch to the vagrant user again, or run the bash command. Okay, that should sort out your problem. Just go back to the root user and then uh, switch to the vagrant user again. That would resolve the your problem. The issue why you get this is because whenever you add the user inside the Docker group, it sets up an environment, okay, which is not ex exported when you are already on that user. So once you go back and switch again, then it will get exported and you would be able to run that command. All right, so at this point, we are able to run the Docker, okay, and we are able to run our first container. So we know that we are not having the installation for the Docker is working fine because we are able to run our first container, okay. So last Ram is saying I am using getting error when I run the curl command. RHL is now only supported for Docker EE. Tulsiram, the thing is, we are not running the enterprise edition, okay, for the Docker. Obviously, that's something. Which operating system you are running? Is it CentOS 7.5? Shailesh, whether I have already told before, whether you are running on AWS or whether you are running on Vagrant, it doesn't really matter. Okay, Docker runs everywhere with the same command. Whatever we are running on our here Vagrant now, the same command will also get executed on the AWS as well. Tulsiram, I have like initially said to go ahead and use the CentOS 7.5. The reason for that is RHEL comes with a license. Okay, so issue is that there are some repositories which are different in RHEL case, and since we are not having the license because it's a paid version, so RHEL is having you need to get some extra things to be done, and because it's an enterprise version, okay, so not everyone will be having the access to here. Okay, we are not having an access to the licensed version of the RHEL, so we can't really download the packages and all. The CentOS is only the open source version of the RHEL itself, okay, but its repositories are open source and packages can be downloaded. That's why we are using CentOS 7.5. And I already told everyone, okay, that we should use the same distribution because uh, initially we are getting familiar with the tool. Okay, once you are quite familiar, you know about how it works and everything, then you can change the operating system. Otherwise, we will keep juggling between these operating systems only. Okay. So go ahead and use the CentOS 7.5 for now because it is already having the repositories and everything configured. When you will run, you will get everything as we are showing to you. Okay, guys, the supported operating system is CentOS 7.5. Okay, if you are, I would suggest everyone to use the same. All right, so at this point, we have run the hello world container. Okay. So similarly, you can use the Docker search command to run any container. Okay. So what we can do is, if we wanted to like get the information about any of the container that we want to run, so you can do Docker search. Okay, like CentOS. Okay. Let's say we want to run the CentOS, so we can do Docker search CentOS, then it will list out all the CentOS version which are available to us. Okay, so we can, if I scroll above, okay, you will see that it has different CentOS available. Like this one is coming with the CentOS, official CentOS. This is an official CentOS version. Okay, and another one is with Ansible. Then there is CentOS Services 6. The version is 6.10. Then there is headless, CentOS 6, MySQL 5.7. So there are like large number of images. What you should always remember is that you should always run the official image. If you will see, it says official OK. Okay, this one. So this is necessary because there are many community additions as well, but you don't know what's running inside the Docker container, so it might be a security issue. I would suggest that you should always download the official Docker image from the Docker Hub. Okay, that is one way of searching the containers. Now, if you directly want to go, you can directly go to the Docker Hub. Okay, we can go to the dockerhub.com. You can create a free account inside the Docker Hub, okay, by simply registering through your email ID. And once you have done that, you can go ahead and search here as well. Okay, so directly provide the base image that you want to use. So here is the CentOS image, and it says this is the official image. Okay, so you can also search from the Docker Hub search console from the dockerhub.com, hub.docker.com. Okay, here you will get a large number of containers for everything. You can search anything. Okay, normally images are for everything. Then you can download the base images from the Docker Hub and go ahead and create your own image as well over and above that image. Okay, so here is the official build for Nginx. You can download the Nginx and then configure Nginx according to your own requirement. Okay, all right. At this point, so if you just want to download an image to your system, okay, because we know that whenever we run a container and if the image is not there on the system, then it looks out for the image. So it's possible that you first download the image onto your system and then run the container. Okay, so if you just want to download an image, so you can use docker pull command. Okay, so we have right now run docker run CentOS. Then you can do something like docker pull CentOS. Sorry, we not run the docker run. It's like docker search CentOS, and you can also run docker pull CentOS if you just want to get the image of the CentOS on your system. So you can do docker pull CentOS. it will download the latest image of CentOS onto your system. Okay. So it is downloading the latest image onto our system. So this is 75.4 MB in size. Okay, you see the actual CentOS image, if we see for a virtual machine, is like 3 GB in size. But if we see a Docker container image, that's only 75 MB. Okay, so you should keep your images really small because it allows you to create a container on the fly. Okay, whenever a requirement is there, you can just run this container anywhere, and it's only 75 MB in size, so it should come up and running very fast. This is the main reason behind using the containers, that the container should come up really early. Okay, and for that the container should be always be smaller in size and should always have the dependencies of the application only. Okay, now the CentOS container has been downloaded on our system. Okay, if you wanted to see what all images of the Docker that you are having on your system, so you can go ahead and run Docker images command. That will show you all the images which are available on your system. Okay, so here we see that we have a CentOS image and we also have a hello world image. The CentOS image, latest image is this. This is the image ID. It has been created 30 hours ago. The size is 202 MB. Okay. All right. So let's run the CentOS now. So we can do Docker run CentOS. Okay. That will run the CentOS container. Nothing happens. Why? Because the container runs in the backend, executes a command, and stops. Now you can directly provide a command here like hostname. So it prints the hostname. Okay. Now what happens? It executes a command inside a container. Okay, and then exits. Why? Because the command is not a long running command. So what you can do is we can, if you wanted to go inside the container. Okay, let's say we want our container to keep up and running and we also want to get inside the container, then you can do Docker run. Okay, interactively. So -i, and you want a TTY, that's a terminal. So you can run Docker run -it CentOS. Okay, so this time you see that we are inside the container. Okay, this is the container ID and we are inside the container. Another thing is, let me show you in another uh, terminal, that if you run Docker ps right now, you will see one of the container is running. Okay, here is the container name naughty boss. Okay, now the status, this is the container ID, this is the CentOS container that we are already running. We are bin bash, we are inside this container. So this container is up and running for 21 seconds ago. Now the important thing is, right now we are inside the container. It has got a bash, which is Linux gives you by default a bash prompt. So till the time we are inside the container, it's up and running. Now as soon as I exit this container, the container is going to stop. Why? Because this is if I run the ps -ef command here, you will see the root ID. That is, the PID one is allocated to bin bash. Okay, And this is because we are inside the container. Now once we get out of the container, this bin bash is going to complete, and because the PID one no longer exists, so the container is going to stop. Okay, so let's do that. Let's we can run exit or press Control D to exit the container. Okay, now let's do exit. So once we exit the container, if I go back to the other terminal and run the docker ps again, you will see that no container is running. Okay, clear up to everyone? So you can run docker run CentOS, docker run CentOS hostname interactively, and then docker run -it CentOS. Okay. All right. Now another thing that I wanted to show you is if you are having, let's download an Nginx image. Okay, so we can do docker pull Nginx. What it's going to do is it's going to download the Nginx image. Let's download the Nginx image. All right, so Nginx has been downloaded now. Okay, at this point, we have seen how we can run the containers. Now we are going to see how we can run the containers in the backend so that they keep on running. So we are going to start the Nginx, but we are going to start the Nginx in the backend this time, so that whenever we run the docker ps command, we are going to see that the Nginx container keeps on running. Okay, so we can do docker run, and for running the container in the backend, and whenever you are going to run any application inside the container, you should always use the -d flag. -d is for daemonizing the container that is running your application as in daemon inside the container. And by default, you should like always remember that you should always run your application as a daemon inside the container. Okay, and this time we are also going to assign a name to our container. Okay, so the name of our container can be web server. Okay, and the image name from which we are going to create the container, that is Nginx. Okay, so this is the command. This will create a long running container of Nginx which is going to run our web server. Okay, so let's press enter now. So you will see that it returns a container ID. Okay, so if I run docker ps now, you will see that the container Nginx is running, okay, for the last 7 seconds. And this time docker does not assign it some random name. Why? Because we already provided it the web server name, so it takes a name that we have provided and does not assign automatically some random name to it. Okay, now Nginx container is running in the backend. Now what we can do is, if you want to go inside this container, okay, you can do it using docker exec -it. Okay, Now you can use the container ID or container name. Okay, let's use the container ID and then do bin bash inside that container. This is how you are going to get inside any uh, production container or any of the container which is running in your environment. This is the safe way of going inside the container. So let's go inside the container. Now we are inside the container. Okay. This time, if I do ps-ef, so ps command is not found. So you will see that even the ps command is not installed on the system. It's just barely running the nginx only. Okay. Now this time, if I going to exit, will this container get stopped? No, because the nginx is still running in the backend. Okay, bin bash is not the prime process which is running. So even if I press Control D to exit this container, okay, this container will still be running. So if I do Docker PS, you will see the container is still running because it's running in the backend. Clear to everyone? All right. There is one more way of getting inside the container. You can attach to a container using Docker attach web server. Okay. So you will also again going to get inside the container. Okay. Seems our container has stopped. Let's start the container again. So the web server has started. Let's try attaching to the container again. Since it's attached, now if I exit this, it's going to stop the container. Okay, so that's why you should never attach to a container, rather do docker exec inside the container. Okay, now if I run the docker ps command, you will see the container is still running. Another thing is I can get all the information about this container using docker inspect command. So I can do docker inspect web server. This time you are going to see that it prints all the information about this container. Okay, so here is all the information about this container. This is the container id, it was created on, path, arguments, state, whether container is running or not. This is the log path where I can get the log of the container, name of the container, how many times it's restart, driver, mount, options, auto remove. Okay, so you can get all the information about a container using docker inspect command. Okay, so let me provide you the commands we have run till now. Sujit, that's not hello.world, that's hello-world. Okay, so do docker pull hello-world, not docker pull hello.world. Okay, now another thing. So it says full access denied on hello.world. Okay. Okay. If you are getting an error, so you might have to first log in to the Docker. Okay. Okay. Guys, it's also possible to log in over the command prompt inside the Docker Hub. So you can do Docker login. Okay. And then log into the your Docker Hub with your username. Okay. And your password. So once you do that, Docker will allow you to download the images that you are having inside your login. Okay, let me try it out if this works. So it says, see, I have logged through my username. So I can go ahead and use my credentials. I can push the images and I can do anything inside the Docker Hub right now. And Docker Hub is going, that would be available to my user only. Okay. This is how you can log in inside the Docker Hub on the prompt itself. Another thing is like we are having the Nginx running right now. So what we can do is Docker stats web server. Okay, so it will print out all the statistics regarding our web server. So here it is. You will see how much CPU utilization is there, how much memory utilization is going inside the container, what is the network IOPS, block IOPS, like this. Okay, so this is actually providing you the matrices of the container. This will help you examine how the container is performing right now. Okay, and then you can run Control C to come out of it. Okay, now if you turn to so Nginx is still running. The another thing that I wanted to show you is you can, if you want to stop this container, you can simply run docker stop Nginx. Okay, sorry, docker stop web server, name of the container. Okay, so the container is going to stop. If you want to start back, you can do docker start web server. That's how you stop and start a container. Okay, now it's also possible to pause the container. So you can do docker pause web server. That will pause the container. So if you do docker ps, it will appear to you that the container is still running, but it's in a pause state right now. So you see the status is paused. So if I try to get inside the container, what happens? So it says that although the container is showing us that the container is running, but it's in a paused state. Whenever the container is in a paused state, you can't even get inside the container. This is temporarily when you are deciding whether you require a container or not. Okay, or if you are having some unfinished work and you don't want the other users to get inside your container, but at a later point in time you will come back and you want that you should have an access to the container, like that. Okay, and if you want to get inside, then you can do docker unpause web server. Okay, this time we can get inside the container. So we are inside the container. Okay, then we can exit out. Uh, it's also possible to up till now we have seen that we can stop the container. So you need to log in, like create a login on the Docker Hub, hub.docker.com. Okay, that's the Docker Hub website. Once you have an account, then you can directly log in through Docker login command. Okay. Another thing is, if you don't want to stop the container, okay, let's say your container is not responding to your command, it has somehow hanged, okay, then you can go ahead and kill the container. So you can, just like the Linux only, so you can actually kill the container. You can do docker kill web server. Now once you execute this, it will kill the container. Now if you run docker ps command, there is no longer the nginx being running on the system. Okay, now if I do ps hyphen a, sorry, docker ps hyphen a, you will see that there are so many containers we have run. Okay, so we can remove the container right now. So let's remove this happy stone breaker. Okay, so what I can do is docker rm happy stone breaker. That's going to remove the container. Now if I again going to run docker ps hyphen a, you will see no longer the container is there. Okay, this is how you can delete a container. Now if I run docker images, how can I remove an image of a container? So this time I will do docker rmi. Okay, remember it's rmi. Rm is for container, rmi is for images. You can remove docker rmi hello hyphen world. Okay, so it has deleted. You need to make sure before the see docker is not going to allow you to delete an image if it is being used by some container actively. So it will ask you that you should delete the uh, container first. Okay, then only it will allow you to delete the image. Then that's how then you will need to first remove the container which are using the docker image that you are trying to delete, and then you are going to delete the image which you want. Okay. All right, so at this point, let's create a container of CentOS and let's see if we can install some packages inside the container. Okay, so we are going to do docker run hyphen it hyphen hyphen name, and let's name the container as CentOS C1. Okay, and then we can just up this container. Sorry, the image also needs to be provided, so it's CentOS. Okay, docker run hyphen it. Okay, let's up this. So the container is up now. At this point, we can run the command inside this container like yum install hyphen which, that will install the which command over there, and we can also install the net tools which will allow us to check the IP of the container. So right now this is executing inside the container, not on our virtual machine, but inside the container that we are running. All right, so which has been installed now. Similarly, you can go ahead and install net hyphen tools inside your container. That's going to install the net tools so that you can run ifconfig command. All right, so that's done. Now, if we run ifconfig command, okay, we are going to see the IP address is 172. Okay, that's also one of the things which confirms that you are right now running inside the container, because we know that our virtual machine is having an IP address of 192.168. Okay, but here we see an IP address of the Docker container. Okay, so let's exit this container using Control D. So we have exited the container now. All right. And now what we can do is docker diff CentOS C1. Okay. So whenever we run the diff command on the container, it's going to show us the difference. Okay. It's going to list all the files, and it's if you will see this hyphen a option, okay, it's showing what has changed inside the container. So when we run the which command and the yum command, it has actually created a yum db. Okay, these were all the files and directories that were created when we run the yum command. Okay, and these were additionally populated, like we installed the which, we installed the net tools, so it's showing us the difference between the base image and the what has changed inside the container. Okay, this is also one of the ways to look what has changed inside the container. You can check a difference. Okay, another thing, we if we wanted to push it on Docker Hub, then we can do docker commit, okay, CentOS C1, and then the name that we want to use to commit. So we can do CentOS hyphen net hyphen v1 v1.1. Okay, so this has been committed onto the CentOS now. Okay, on the Docker Hub, and this is the 256-bit and this SHA-256 bit is used to check that the package that we have on our local system is also on the Docker Hub. So this is a way of verifying that whatever the size and the files that we are having on locally, it's also on the remote. Now you can go ahead and remove this CentOS C1. Okay, so we have removed now CentOS C1, and now what we can do is we can again run the Docker container. We can do docker run hyphen rm hyphen it hyphen name. Okay, and this time we are going to create a CentOS C2 from the image that we have pushed onto the remote. So we are going to again use that image, and it's going to create a new container for us. You see, we are inside the container now that we have committed inside the Docker Hub, and now we can press exit, and that container would be removed. Okay, so docker commit is used to push the container inside the Docker Hub repository. Okay, And hyphen hyphen rm command deletes the container whenever we exit the container. Okay. All right. That was all there to the Docker commands that we need to know for running the Docker containers. Okay. So I hope this is clear to everyone how we can go ahead and create the containers. Okay. And delete the containers, maintain the containers, get inside the containers, install the tools, check the differences, commit the containers, things like that. Okay. So this is all you need to know about the command line of the Docker. Okay. The another thing is right now there are three things left. Okay. One is how we can create our own images in the Docker. Okay. That's the very first thing. Then we need to see if how we can create our own repository and how we can push the images that we are creating inside that repository. Okay. And the third thing is the Docker networking. Okay. So should we take a break or you want to proceed on the Docker registry now? All right. So let's proceed on the registry now. All right. So till now we are using the Docker Hub to download and run our containers. Okay. But we can also use our own registry to run the containers. Okay. So let's run the containers on our own registry. Okay. Now Docker registry is another application. Okay. So it has already been created and packaged inside the Docker. So we can run the Docker registry just like any other application, and we should be able to create our own registry. Okay. So let me clear the screen now. And what we can do is we can directly run the Docker registry here itself. We can do Docker run -d for running the Docker registry in the backend. Okay. And then we can do -p for specifying the ports on which this Docker registry is going to listen for the requests that the other VMs, like the other Docker machines, are going to raise out to our registry. Okay. So -p is for specifying the port, and the port number is 5000. Sorry, -p 5000. That's inside both the VM as well as the container. Okay. So our registry is also going to listen on the 5000 port. And then we are also adding a flag that it should always restart the container if it's not already running. Okay. And this always flag will always restart the containers when the somehow the container gets stopped. Rishi, I will answer that shortly. Okay. And then you can provide the name of your image that you want to run, uh, name of your container. So name of our container would be registry, and the image that we are going to use. So we are again going to use the registry image, and we are going to use the second version of it. Okay. So we have also specified the version. Okay. So registry :2, and when we run this command, this is going to create a Docker registry on our system, inside which we can go ahead and use it to push any images. Okay. Our own images, whatever images that we are creating in our environment, we can push that inside our own registry. So run this. Okay, it says that it's not able to find. Now it's going to download the registry from remote Docker Hub and going to install it. For Rishi, for logging out from the Docker Hub, you can simply do Docker logout, and that will log out from you from the terminal. So you will see at this point the registry has been downloaded and it's also running the container. So if I do Docker PS, you will see the registry is running. Okay, so we are good to raise the request on the 5000 port and push the images inside our own registry. Okay, so at this point let me download Docker pull access denied for registry. You have Soham put there's a mistake like TRY. You have used registry in TRY. That should be TRY. It should be REGISTRY. Okay. Replace. Okay. That should solve your problem. All right. So the registry is up and running now. Okay, and now we need to push a image inside our own registry that we are going to use. Okay, and not the Docker Hub. So what we can do is we can pull the image of uh, Ubuntu 16.04. Okay, on our VM. First of all, we are going to download an image. Okay, then we are going to tag that image that it's our local image, and then we are going to push that image inside our own registry. Okay, so you can pull the image using docker pull command. Okay, let's download the Ubuntu 16.04. So here it is downloading the Ubuntu 16.04 on our machine. All right, so the Ubuntu 16.04 image has been downloaded now, and we can tag this image, okay, using the docker tag command. Okay, so we are going to tag it as docker tag Ubuntu 16.04 that we have downloaded. So we are basically referring to it right now. Okay, so we are referring to this image and we are saying that tag this image as localhost. Okay, because this is our local image. Okay, and inside the port 500, so that we can easily identify this is our local image, and we can going to put it as Ubuntu non-prod because we are going to create our non-prod environment using this image. So we are basically saying this as this is our Ubuntu based image which will be used in our non-prod environment. Okay, so just run this command. This will tag the image as localhost 5000 Ubuntu non-prod, and then we can push the image inside our own local registry. For pushing our image, you can do docker push. Okay, this is the command for pushing the image inside our local registry. The server name, which is localhost, port on which your registry is running, which is 5000. Okay, and the image that you want to push inside the registry, which is you want to non-prod hyphen non-prod. Okay, let's run this. So it start pushing the image inside our local registry. Okay, there it is. Okay, so this has been pushed inside our own registry. Now let's test that we are able to pull the images from our own registry and able to run the containers, not from the Docker Hub, but from our own registry. Okay, for that, let's check the Docker images first. Okay, so we are having an Ubuntu image locally. So we first of all need to remove this. Okay, to make sure we are only running the image from our local registry and not from the Docker Hub. Okay, so you can do Docker image remove, or you can use the RMI command as well. It's up to you. Okay, and Ubuntu 1604, which we previously downloaded from the Docker Hub. Okay, so it untags and removes the Ubuntu 1604. Okay, and then we are also going to remove the local host 5000 image that we created earlier, because we already have this inside our local registry. We are going to pull it from there. Okay, so we are removing localhost colon 5000 slash Ubuntu non-prod. Okay, so it deletes that image as well. If we run the Docker images again, you will see that we are not having any Ubuntu based image on our local system. Okay, now you can also run command like docker image ls, that will show you all the images. Okay, so you can run docker images or docker image ls, both are almost same. Okay, and now we are going to pull the image from our local registry on our system. Okay, so what we can do is we can do docker pull localhost colon 5000. Okay, and then the name of our image, which is ubuntu hyphen non-prod. Okay, so what this is doing is it's going to pull the image, this time not from the Docker Hub but from our own local registry where we have the images. Okay, you see it's downloading right now and it's comparatively faster. Why? Because it's running locally. All right, so it's done, and if I run the Docker images, so you will see the image is there. Okay, clear to everyone how we can create our own registry? All right. Now let's see how we can create the our own images. Okay. Till now we were using, yeah, so we can go through it once again. Okay. So what we have done is we have first of all run our own registry. Okay. So here you will see we up our registry, okay, and then we actually downloaded the image from the Docker Hub, like the new image for Ubuntu 16.04. Okay, once the 16.04 was downloaded, we tagged the 16.04 as localhost 15 on our localhost 5000 port Ubuntu non-prod. Okay, then we push the uh, Ubuntu non-prod image inside our private registry. Okay, that is the own registry. So this is what you want to know, right? What we did just now, our own registry. So you can create, very first thing is like how to create the registry. You can create the registry by downloading the registry image and running your container. Okay, this is the command we use to run the registry on the 5000 port. Okay, now once we have run the registry, we downloaded the Ubuntu image on our local system. Once the Ubuntu was downloaded, then we tagged the Ubuntu as localhost 5000 Ubuntu non-prod. That is the image that we are going to run on our non-prod system. Then instead of pushing to the Docker hub, we push the image inside our local registry, so it's available on our local environment only and not to all the users, public users. Okay, so this was pushed inside our local registry. Then we checked how many Ubuntu images we are having locally. So we were having two. That is one downloaded from the Docker Hub, another one on our that we pushed inside our own local registry. Then we remove both the images. Okay, and then we again like downloaded like we from our own local registry. Okay, and it was there, so it's confirmed that we are able to download it. Yeah, Krunal, I can give you all these command, okay, after the session, so you can download it. I will share the history of all the commands with you. Okay, so I think you can go through the recording in case. It's removing the previously downloaded image because we previously created it locally. Okay. So I just wanted to show you that if it's not available locally on your system, then also you can download it from your own private registry. If it was available locally, then it would not have checked inside our private registry. It would have directly use the local image. That's why we removed the local image first from our system, and then we downloaded the image from our private registry. Okay. All right. So we are going to start with the how we can create our own uh, images. Okay. Yes, Soham, so Docker images gives you what images you have on your local right now. Okay. Soham, whenever you are going to push the image inside your own local registry, okay, then there is not an indexing directly available, so you can't list as in the Docker Hub, okay. Uh, Rather, you can create an index like where what images you have pushed, but it's not directly accessible for the search like that. Another way that you can query is through the APIs. Okay, so a get API will work, but that's a different way. Okay. So whatever images that you have pushed, you need to keep an index for that. Right now, I don't think there is any of the direct mechanism. There is one of the ways of using a get request to directly query your registry, but that's like out of scope of what we are doing right now. Okay. So whatever images that you are pushing, you can keep a track of it, what images that you have pushed inside your own registry. It's not directly searchable. Or one of the ways can be localhost colon 5000 slash redo slash. Okay, so you get it how we can query the images inside our local. See, directly over the command line, it's not possible. You will have to make a RESTful call to your registry of what images lies inside your registry. Okay, so if you make a call like this, it will show you in the key value pair what images are available. Okay, that is one thing, not from the Docker, but from the curl command. That's a web request. Okay. Another thing is you can even list the tags which are there on your images, because this is showing you the image name only. Okay. And so we can do something like this as well. Okay. So you see the tags as well. Okay. Through this command, we are able to see what images are there. Curl localhost 5000 v2 slash underscore catalog. Okay, this will list the images that we are having. Then by entering the name and tags and list, you are able to query the tags as well. Okay. Okay, Soham, that answers your question. We created our own registry, Soham, private registry, and we pushed inside images inside that registry. And then right now from the Docker, it's not possible to query the images from our registry. It's not going to search inside our own private registry. Okay, but you can see the images using the curl command and sending a web request to your office, to your registry. Okay. All right, and now let's move on to another example of how we can create our own images. Okay. All right, so see the guys, I'm going to share all the commands with you. Okay, later when the session is completed, but for now you can use this underscore catalog and curl localhost colon 5000 v2 v2. Okay, these are the commands which you can use. Now let's talk about the Docker images. So let's try and understand this from an example. Okay, so let's say we want to create a Docker image, okay, which will be having all our dependencies of our application, and we are going to create here a Docker file, and Docker file is going to have all the instructions for running how to create the container. Now, in our example, we are basically going to create an Nginx web server over the Alpine Linux. Okay, what is Alpine Linux? Alpine Linux is similar to the Ubuntu. That's a Debian-based operating system, but it has been stripped of just 5 MB. So Alpine Linux is just a 5 MB image. So we are going to install the Nginx over this Alpine Linux, and then we should be having a index.html inside our uh, web server running, so that we can make a request to our web server, and then it should deliver that index file to us, and all of that should be automated, okay, through a Docker file. So we are only required to do two things, that is run the web server and through the Docker run command, and run the create an image. Okay, and everything else should be automated. So let's create a Docker file and see how we can automate this. Okay, so very first thing that we are going to do is we are going to create an index.html file that is going to be run by our web server. Okay, so I'm going to delete this one, and I'm going to create a new index.html file. Okay, inside this, we are not doing much. We are just simply going to print a header of hello world. Okay, so I'm just creating a heading like hello world. Okay, and close this heading. So this is our index file. Okay, now let's create a Docker file. Okay, Docker file is what is used for creating the images on the Docker containers. Okay, so very first thing that you are going to start, you are going to tell which base operating system you are going to use. So we are going to use the Nginx Alpine Linux. So use from okay, and we are saying that nginx colon alpine, okay, and we are going to copy the image file from our current directory to /usr share nginx html, okay, and that is it. That's all is required, okay. So let's create a repo directory and move the index.html file and move index.html file inside the repo directory, and also move the docker file inside this repo directory. Then we are also going to go inside the repo directory. If I show you the index.html file, this is our index.html file, and if I show you the docker file, uh, then this is our docker file, okay. So what we are doing is we are just using the nginx image, okay, nginx alpine image where the nginx has been installed on the alpine linux, and we are just copying the index.html file inside the usr share nginx html from where the web server is going to run and deliver this file to us, okay. So let's create an image and see how we can use the docker build command, okay. Now at this point we are good to go ahead and we can do docker build for building our image, and we are going to provide a tag to our uh, contain image that we are going to run. So we are going to simply say this as web server hyphen image, okay, colon v1. V1 is the version of the image that we have just created. We can go ahead and create more versions out of it. So this will allow us to create the first version of the image, okay. Now just press enter. Docker. Okay, we haven't specified the current directory. You also need to specify the directory, okay. For specifying, if you are inside the directory, you can just use a dot, okay, over there, and it means the current directory, okay. So this will uh, send a request to the docker daemon. It will download the nginx alpine linux and going to copy the index file that we just created here inside the container, and going to start the nginx is going to start and deliver that image to us, okay. So you see it's just a 5 MB image. So the container has been our image has been created. We can verify this as by running docker images command, okay, and you will see the web server hyphen image is there, tag is v1. This is the image id which is just created 9 seconds ago, okay. Now we are good to go ahead and we can run our container, okay. So we can do docker run, and we are going to run this container in the backend. So hyphen d, okay, and hyphen p is for specifying the port. This is a web server, so it's going to run on port 80, okay. So port number is 80, and then the image name, so that's web server hyphen image colon v1, okay. This is the image we are going to use to create our container. Just run this command. It will provide you an output of a container ID. If I run docker ps command, then you will see there is a container ID matches this one, okay, and the web server image is running right now on our system, okay. So if I wanted to check that the same image, the index.html file is delivered or not, I can do curl docker command, okay. This will send a request. I need to stop this one first. Let's stop our registry container, okay. Now registry container is stopped, and if I docker ps, then only the web server is running. So I can do docker curl docker. Okay, so I can send a request to my container. I'm running it on port 80, so I can send a request to this VM, or VM is this. Okay, let's try and open this in a browser and see if we are able to run it or not. Okay, so you see hello world is there. So this shows that the Docker container is delivering the index dot HTML file, which was having the hello world inside it. This is our index.html file. Okay, and this has been created over here. So our image was created, and our container is running now. Okay, now let's make it little more complex from what we have done till now. Okay, and it's possible. Let's go back to our docker file. Okay, and now at this point we expose the port in the command line. If you will see that we expose the port over here, docker run command, we told which port our container is going to run. It's possible that we specify inside our docker file only. Okay, and we can directly expose the port inside this using the expose keyword. Okay, and we can specify the port. Okay, like 80 space 80 here itself inside the docker file. Another thing is we can also tell how to start the nginx. So we can run the nginx as a command, not in a daemon mode but rather as a command. So we can do nginx -g, and we are this time not running it as a daemon, so we can say daemon off. This is the command. This is going to run the nginx in the front end. Okay, and then we can again run the docker build command, and this time we can say it as web server image v2. Okay, so it's exposing the port, and it has also uh, uh, created the v2 version of our image. And then what we can do is we can do docker ps. So the initial container is running. Let's stop that container and run this one as this time. Okay, let's run this one. Okay, and we don't need to specify the port. If we do docker ps, we will see that the uh, web server image v2 is running on port 80 itself. Okay, so Yes, we are just having a break. Okay, so that completes our Docker build command as well. Okay, now the only thing which is left is our networking. Okay, so next we are going to start with the networking. Okay, so before that, let's take a 10 minutes break, and then we are going to come back and see the Docker networking, how we can create the networks and how we can verify the networks. Okay, so let's take a break of 10 minutes and then we will be back. All right, so everyone back. Sujit, where did you get that error? What command were you executing when you get this error? Sujit, can you share the command? Sujit, which operating system you are using? This seems that this error occurs when you are having an outdated kernel version. Okay, so you will need to update your kernel version to 4.20. Just do uname hyphen a. Okay, uname hyphen a. It will show you the kernel version, and you will have to upgrade. That should be 3.10 in your case, and you will have to upgrade it to 4.20. Okay, so upgrade it to kernel 4.20. That will solve your problem. All right, so let's continue ahead. Okay, so the only thing which is left now is the networking. Okay, inside the Docker. So let's start with the Docker networking now. Okay. Okay, so you can check out all the networks which are available using the Docker network command. So you can do Docker network ls, and that will show you all the available networks, that is bridge, host, and none network. Okay. Once this has been done, you can use the Docker network inspect command to inspect a network. Okay, so we can do Docker network inspect and bridge command. Okay, so it will give you all the information about this network. Okay, the most important information is the IP address. This is the subnet which has been created automatically when we install the Docker. The uh, thing is that this IP address is only available for the containers that we are creating on this machine. Okay, it can be assigned to any of the virtual machine. Okay, and this can be used by the containers to interact between themselves. It's a /16 subnet, so we can create around 32,000 containers on this machine from a network point of view. If you have to create more containers than that, then you will have to choose even bigger network than this. Okay, and similarly, also, if we see the etc host file, okay, of this of a container, we need to create a container, if we see any host file, let's go inside this running container. Okay, so we can do docker exec hyphen it, okay, and bin bash. So we are, okay, let's run our CentOS container. We can do CentOS hyphen I docker run hyphen it CentOS, okay, bin bash. So if we go inside the Docker container, inside in the etc host file, you will see that whatever is the container ID. In our case, the container ID is 60F7CF1. Okay, and here's the IP address. So it makes an entry inside the etc host file so that whatever container hostname is being set up, it resolves to the IP. Okay. Now you can create your own bridge network. Okay, you can customly create your own bridge network as well. Let me exit the container. Okay, for that you can use docker network create isolated bridge. Okay, so we are basically creating an isolated bridge network. So it has created the network. Now you can do docker network ls to check your available network. Okay, and sorry, it hasn't created docker network create. This should be isolated underscore bridge. Okay, uh, so it creates the network, and if I do docker network ls, you will see that an isolated bridge network has been created. We can now do docker network inspect isolated underscore bridge. So it will provide you the subnet. You see, previous one was 172.16. This is 172.18. So it's a different network that we have created. This is how you can create an isolated bridge network in your case. Now, if you wanted to run a container inside your bridge network, then you can do docker run hyphen it, okay, hyphen network isolated underscore bridge hyphen name. Okay, uh, we are going to use the CentOS base container, and the image will be CentOS, and we are going to run the bin bash inside it. Okay, so the container has been created. Now you will need to you can connect to that network using docker network connect isolated underscore bridge and the name of the VM that you have run. So we have run the CentOS. Okay, and let's, okay, right now actually we are inside the container. That's why it's showing us that. Let's exit the container and then run this command docker network. Let's again create one more container using the hyphen d option. Okay, so that the container runs in the backend. Sorry, after run this will come docker run hyphen d. We are not running this in interactive mode, so it's already running Okay, the container is already running, that's why it's showing this. So let's connect to the network. We can do docker network connect isolated underscore bridge CentOS. Okay, and if we do docker ps, now you can disconnect using the docker network disconnect option. Okay, and you, if you want to delete the isolated network which you created, so you can do docker network rm isolated underscore bridge. That deletes the new network that you have created. Okay, so that was about the docker networking, how you can create an additional network, how you can run the container inside that isolated network, how you can attach to the network, how you can detach, and how you can delete the network as well. Okay, and disconnect and remove the network. That was about the docker networking. Next thing that you want to do is like the docker compose. Now docker compose is used when you are going to run the multiple containers, like in a microservice environment you are going to run the multiple containers. So if you need to start the multiple containers at the same point in time, then you can use the docker compose command. Another thing is, whenever you are running the docker compose, then you would be able to execute everything. Even the containers will come up and running when as soon as uh, you run the docker compose command. Okay, so let me show you, then it will become more clear to you. Okay, so let's install. The very first thing that you need to do is you need to install the docker compose. Docker compose is shipped as a library, so you can directly download it from the github and then provide it the execute permission. So just execute the command which I have provided you in the curl. Okay, this is the command. So what it's doing is it's going to the GitHub repository and downloading the Docker Compose according to your operating system, and it copies it inside the /usr local bin Docker Compose, so that it's available for all the users. Just download it. Okay. Okay, so you need to run this as a sudo user. Okay, because vagrant user will not have permission to copy inside usr local bin. Okay, let's do it from the sudo user. So it gets downloaded. This is the binary I am talking about. This is basically a binary file. Okay, for the Docker Compose. If you will see, this is your Docker Compose file. Okay, now you need to provide it the execute permission because it's a binary. So we are going to execute this binary. Okay, on our system. So let's provide the execute permission to this file. Okay, so now what we are going to do is we are going to run an SSH inside our uh, Docker Compose file. Okay, so let's create a directory. Okay, and then we are going to run our application inside that. So what Docker Compose needs, it's you uh, we are right now inside our repository repo file. Okay, so if we list all the files, let's remove all the files first. Okay, so it's an empty repository now. Now we are going to, very first thing that you need to do is you need to create a Docker file. Okay, so let's create a Docker file. Okay, this time we are going to use the CentOS based image. So let's use CentOS latest. And then we are going to install the OpenSSH server on our Docker container so that we can SSH inside our container. So we can do yum install -y open SSH -server. Okay. and then we are going to go inside. We are going to create an directory called var run sshd for running our SSH server. Then we are going to add a user. Okay, let's say we are adding a user. So we can directly add a student user. Okay, let's name this as student, and let's set up the password for this as well. So we are going to set up the password as sudo only. Okay, student only. So let's set student colon student. Okay, and an echo here, and we are going to echo this password inside the chpasswd command. Finally, we are going to run the ssh-keygen command to create the key of the user. So we can do ssh-keygen-trsa-f. The file in which you want to create it would be etc ssh underscore host underscore rsa underscore key hyphen q hyphen n, and we are not passing any uh, password to this key file. Okay, which would be required. So, and we are exposing ssh runs on port 22. Okay, and we are going to run the command, that is we are going to start our ssh daemon. Okay, so we are going to execute slash usr bin sbin slash sshd. Okay, and we are going to run it as a daemon, so we can pass hyphen t. Okay, so this is the docker file. Here what we are doing, we are just installing the OpenSSH on our CentOS based system. Once the CentOS system has been installed, then we are going to use the yum to install the OpenSSH server. Then we create a SSH directory, SSD directory, add a student user inside the Docker container, then set up the password for that student user and set up the keys for that student user, expose port 22 on our Docker container and start the SSH server. Okay, so let's save this. Okay, so our Docker file is ready now. Next thing that we need to do is we need to get our Docker Compose up and running. Okay, so we are going to create a Docker Compose YAML file. Okay, so let's create a Docker Compose file. So very first thing that we have to specify is the version of our file. So let's say its version is 2. Okay, and the services which we are going to run, so we are basically running the sshd service right now only. Okay, so let's do sshd, and then we are, you have to indent by 2 spaces every time you put a colon. Okay, so build, we are building an sshd service, and the image that we are going to use. Okay, so image that we are going to use is CentOS hyphen sshd colon latest. Okay, whatever be the this, we are going to name it as this image, and the ports that we are going to use. Okay, another thing is port will be on the physical host, we are going to open it on 2222, and inside the container we are going to run it on 22 port. Okay, now additionally we are, here is our Docker Compose file if you want to have a look. Okay. Now the service that we are running is SSHD. So we will have to create a directory with that service name. Okay. So we are going to create an SSHD directory. This is our service that we are running, and we will have to copy the Docker file inside the inside this directory. Okay. So let's move the Docker file that we just created inside this SSHD directory. Okay. And finally, you can start the Docker Compose with Docker Compose up -d. Okay, seems there is some issue with the Docker file. Just a second. So build we have specified, image we have specified, and let's move out one directory and rename the repo folder as Docker Compose folder. Okay, and if we go inside the Docker Compose folder, we are having an Docker Compose file. Okay, and we are also having an SSHD. So this looks good. If we run the Docker hyphen compose up -d, I think the binary that we have downloaded is having some issue. Let me quickly take a look. I believe the binary is having some issue. Let's rerun the binary. Okay, let's remove this one. I'm not sure, like the binary is not properly downloaded. Okay, and we are going to download the binary again and then run the Docker compose. So let me execute this again. Okay, and this will download the binary. All right, and let's execute, provided the execute permission on USR local bin Docker compose. Okay, and let's run the Docker compose up command again. All right, so we were able to run this time. The binary was having the issue that we previously run. Okay, and I see we are having an some error in our Docker file. Failed to execute the command. Let's see our Docker file. What error it's having. So which command it has failed? Okay, the I have got it. What has happened is here it should have been -y. Somehow I typed it -u. That's why it's giving an error. So let's change this to -y, and let's bring the Docker compose up again. Okay, so if we run the Docker compose up -d, it should bring up the image. Okay, and install the OpenSSH, and once it has been done, it will start the container as well. There we go. So it's right now installing the OpenSSH. The very important thing why the Docker compose is being used is no package. Oh, okay. Yeah, Tulsiram actually pointed that out. That should be OpenSSH. It's like we are missing the N over here. Okay, so it's OpenSSH -server. Okay, let's execute it again. So the very first thing, the Docker Compose helps you to create the entire container up without running anything manually. Okay, so it will create the image, it will create the container as well. Okay, and when you are having multiple containers to run, you can keep on putting them inside this YAML file, and all the containers would be run for you automatically. Okay, so as many containers as that you are having, you can run all those containers up and running using Docker Compose. So this is a good practice, that instead of running the commands manually, once you have gained the expertise with the Docker, then you should work with the Docker Compose so that everything can be worked as an code. Okay. So there we go. It is installing. It has retrieved the keys, importing the keys, and installing the OpenSSH. Okay, so it's installing the OpenSSH right now. No, Tulsiram, Docker Swarm is different. You can add multiple nodes, while Docker Compose is just to bring the multiple containers up, right, for multiple services. When we will reach down to the Docker Swarm, then I will show you how Docker Swarm works. You will understand the difference between Docker Swarm and Docker Compose. Okay. All right. So at this point, uh, if we do SSH hyphen p 4 times 2 student at the rate localhost and select yes, it asks us for the password, which is student, and we are inside the student container. So you see, Docker Compose bring up the entire container up so that we don't have to run any of the manual command. We return down everything and just run Docker Compose up hyphen D. So containers come up automatically. Image was created, containers are up. Okay, and we were able to SSH inside the container. Now, if we just want to bring this down, so very first thing that you can do is you can see your container is up and running. There you go. Okay, so CentOS SSHD is running. Now if you want to bring it down, then you don't have to run docker stop on this container. What you can directly do is docker compose, docker hyphen compose. Okay, and you can simply say down. Okay, so docker compose will stop this container automatically, and whenever you want this to be up again, just do docker up hyphen d again, and it will bring back the containers up. Now, as many services that you have created, you can keep on creating the containers inside the docker compose, and whenever you run the docker compose, all the services will come up. Okay, everything will come up, then everything will go down. It allows us to create the environments on the fly, like the dev environment, stage environments. Okay, we can put everything inside the docker compose. We can create everything inside our repository and commit that inside the GitHub. Now we can share anyone, any at any place, and we can run it anywhere in our physical machines, in the AWS cloud, in the Google Compute cloud. We can just run it anywhere. Okay, because we just need to run docker compose up hyphen d, and it will bring our entire environment up and running. That is the main advantage of docker compose. Okay, so I hope that's clear to everyone how to run the docker compose. So that completes the docker. Okay, and let me share you the complete history of the commands that we have executed so that you can practice out. Okay. Sorry. Let's go to the github.com. Okay, and we can go inside this automation. And what I can do is it's not showing, create a new file. Okay, and let me paste all the docker commands here. so that you can go ahead and use them. And I'm going to copy the entire history. Sorry. Over here. Okay, so that's the entire history, and I can put a commit over here. All right, so that's done, and so you can download this from my repository. Okay, let me share the link with you all, and okay, so everyone, you can download the commands for the entire lab from this repository. Okay, anyone having any questions regarding the Docker? So this completes our Docker lab. Okay, and next we are going to start with the chef. Okay, anyone having any questions? All right, so yes, Soham, tell me. Yes, Soham. See the repo that which we created. Okay, if you create it on one directory, one VM, and then you try to access it from the other VM, so you would be able to use it. Okay, provided you have opened the firewall ports and all of those things. Okay, it will be running on 5000 port, and you can provide your VM1 IP, and then you can call the images on the VM2 from the VM1 IP. That's possible. Okay, you can try doing it. In case you have any difficulties, uh, you can reach out to me. Okay, so what we have done today is exactly what you have to do. That's the entire walkthrough. There is no change when you are doing on the another VM. Okay, just specify the IP instead of localhost. Specify the IP of the first VM and colon 5000 port, and that should do it. Okay, just replace the localhost with the IP, and that's it. You don't have to do any other change. How can I check this messages after while seeing a recording? Mansi, we have shared the entire commands, okay, that we have used in today's lab inside the Git repository. You can download all the commands from there. So whatever I have shared with you in the messages, okay, everything is there inside the Git repository, all the commands, and you can download from there and see the recordings as well. Okay. And whatever I'm sharing you in the message window is also done on the command prompt. So you will see that same commands I'm sharing you in the command prompt, and I have also shared it on the Git repository, so you can download from there. Then you don't have to, you can directly use those commands to practice along with the labs. Okay. Any other question? Should we start with the chef now? Everyone? Uh, Sanjay, it's not next week. Chef, we are going to start in more depth tomorrow. Okay. So let's just cover the basics for the chef, and then we are going to end our today's session, and we are going to cover the chef tomorrow in the tomorrow's session. Okay. All right. So whenever we talk about the chef, chef is basically your configuration management tool. Okay. Up till now, we were going through the Docker, and we saw how we can use the containers and run the application through the containers. That's a more modern approach. Okay. And you will see companies have start adopting it, but there are large number of companies which are out there and they are still running on the virtual machines. They are not using the containers, but rather virtual machine. Another thing is, if we talk about the databases, okay, like your MySQL, Oracle, Mongo databases, okay, then uh, those databases should be run on the virtual machine and not the Docker container. Now you can run those inside the Docker containers, okay, but ideally it's a stateful application. Okay, that is, this data is critical and containers can go down anytime. Okay, so they needs to be restarted. But if your database goes down, then it has recovery and everything built in inside it, due to which it might take database time to come up and running, and it has to maintain the data integrity as well. You can't lose your database data, so it's not recommended that you run databases on the containers, but you can do it, but it's not recommended. Okay. Now the things comes that if you are having the virtual machines and databases running in the virtual machines as well, so, and there are large number of virtual machines, so how do you manage those virtual machines? Let's say there are 1000 virtual machine or 10,000 virtual machine, so it's not possible for you to manage that manually, and that you go on each virtual machine and then execute some command and things like that. So it's possible that we are having an Nginx that we have to run on like 500 machines. So how do we do that? If it was on Docker, it would have been easier, right? We can just specify the container and we can keep on creating the containers like that. But we are not on containers, we are on virtual machine. So whenever we are talking about the configuration management, just forget about the containers and focus on the virtual machines. Now, if you are on a virtual machine, you have to do it manually, but it's not possible for you to do it manually on so many VMs altogether. Okay, so you need a way, a tool which can manage your everything on the virtual machines. Okay, and that's what the Chef is. Chef works on client server architecture. So we are going to run the clients on the different VMs which are going to interact with the centralized Chef server. Now, every client is going to download the policies from the Chef server and going to execute on the VM to make them compliant. This architecture allows us to even manage 10,000 servers, because we don't have to log into each server and run the commands manually. Rather, all the clients are going to call the chef server and going to execute the commands from there. Okay, and we are just going to create one VM, which is our workstation, where we are going to write all the automation regarding the chef inside this chef workstation. So whatever we have to create a recipe, we have to create a cookbook, or we are using knife, whatever we are doing it on a single VM. That VM, that workstation is going to interact with the chef server. We are going to push everything that we have written in the automation to the chef server, and then all the clients which are running in our environment will make a call to the chef server, going to download the recipes, going to execute it, and achieve the desired state. This is why chef is being used. It allows you to write your infrastructure, your configuration, everything in the form of a code. Then once it has been written as a code, then you can integrate that code with your version control system like Git, which we covered previous session. Okay, and you can maintain a centralized repository where you are going to keep this code. Now, whenever there is a change, let's say you are adding an additional website into your Nginx, or you are making some application changes, you are deploying an application, you are creating a new server. There are so many things. Okay, so every time you do any of those tasks, you are going to make a change in your repository. If the changes works good, then it's fine. If something breaks, you are going to revert back to the previous version and going to commit everything. Okay, so you don't have to run any of the commands manually. You are going to write the automation for everything, and then you can commit it inside the repository, and chef is going to implement it for you. This is the most important part, and we are going to cover the chef, Ansible, Puppet, and Salt. All the four are the configuration management tool. All of them work on this principle only. All of them achieve this desired goal only. Although there is a specific learning curve for each tool, different syntaxes, commands, and all those things would be there. So it depends upon company to company, but all four are the major ones, and you will find that they are very extensively used in an organization to create the VMs. Why? Because even if you have to run the Docker containers, you are going to run them over the virtual machines only. Okay, so first there will be a virtual machine, over that the container would be running. So still needs to create a virtual machine, still needs to uh, make a virtual machine into a certain state that we achieve through the configuration management tool. Okay, so is it clear to everyone why we are going to go ahead and learn the chef or the configuration management tools? Anyone having any questions, you can ask now. Otherwise, we are done for today. Okay, and we are going to start the chef in detail from tomorrow. Amongst the four configuration management tool, Ansible is now most widely used. It is very easy to learn. It is having less learning curve. Chef and Puppet both are written in Ruby, and they are having more learning curve as compared to Ansible and Salt, which are written in Python. Okay, but you don't need to know Ruby or Python to learn these tools. Okay. All right. Anyone having any questions? Please let me know. Otherwise, we are going to start the chef in tomorrow's session. All right. Then thanks everyone for attending today's session. I will see you all tomorrow. Okay.